first, and then I have one extra question here. So this last question is the last question that we didn't finish last time, and it's similar to the last homework problem. So once I help you with the last homework problem, I'll give you a few minutes to attempt this one, okay? Okay, well, let's take a look first at number 3. Okay, so the question was, the Senate has 100 members consisting of 55 Republicans and 45 Democrats. And we want to know, in how many ways can we choose a 5-person committee consisting of 3 Republicans and 2 Democrats? Okay, so we have 100 members total, 55 of them are Republicans and 45 of them are Democrats. We want to choose a 5-person committee, and it has to consist of 3 Republicans and 2 Democrats. Okay, so immediately you might say, okay, we have 100 people and we want to choose 5 people for a committee. So this would look something maybe like 100 times 99 times 98, 7 times 96 divided by 5 factorial.
5 factorial. Right? Yep.
So this is how we've been doing the questions so far. But this question has another twist, because we can't just choose any 5 members from the 100 members, because then this would also include if we choose 5 Republicans, right? Because we could, this result here means that we could choose 5 Republicans from the 100 members. But the question very clearly states that we want the 5-person committee to only have 3 Republicans and 2 Democrats. Okay, so we can't have 4 Republicans and 1 Democrat. We can't have 1 Republican and 4 Democrats. And this answer we have right now has all of those. So this is not the correct answer. This is not how we want to do it, right? Now, in the hint, I wrote that we should consider these as 2 separate counting problems and then combine the result. Okay, so let's take a look one more time. Let's try to consider it 2 different. So instead of saying the Senate has 100 members and we want to choose 5, let's just start with the Republicans, okay? So we have 55 Republicans. We have 55 Republicans, and we want to choose 3 of them, right? We want 3 of them, okay? So knowing this, do you know how many possible combinations of Republicans we can choose?
Republican, we can choose 55, wait, 55, 3 we can choose.
Sorry, what was it? What was that?
We can choose 3 Republicans.
Okay, so yes, we can choose 3 Republicans from the 55, but do you know how many different combinations of Republicans we can choose? Because they're all different people, right?
Yeah, 55 times 54 times 53.
Perfect. So you're saying 55 times 54 times 53. Okay. Now there's one more thing we want to do, because yes, this would give us the total number of Republicans we can choose, but if we leave it like this, then we're saying order matters. That means if we choose Bob, Jason, Alex, and Alex, Jason, Bob, we're counting that as a different set, right? But really it's just the same set in a different order. So what do we have to do to this to account for those same sets in different orders? We have to divide it by something.
We have to divide it by 2.
Not 2, right? Because remember, there are 3 people here, so we have to divide it by
3.
So 3. 3. You're getting closer. Don't guess. Okay. Let's just go to an example. Pretend we choose John. Oops. Let's say we choose John, Bob, and Alex. Okay. So remember, we want to divide the number of different ways that we can order John, Bob, and Alex. Okay. So let's just see how much ways we can order John, Bob, and Alex. Okay. So we have JBA. We can then do John, Alex, Bob. Okay. Now we get Bob first instead, then John, then Alex. Then we get Bob, Alex, John. And then finally, there's when Alex comes first, and then Bob, then John, Alex, John, Bob. Okay. So just for choosing 3 people, John, Bob, and Alex, we can order them in 6 different ways. We can order them with 6 different ways within themselves, right? But if the order matters, these would be 6 different permutations, right? Because the order matters. We're saying JBA is different from JAB. But for combinations and when we're choosing committees, the order doesn't matter. So these 6 ways are actually just one way This is just one combination. Okay, it's just one combination, right? So what do we have to divide by to account that we're off by a factor of 6? Right? So we're repeating everything 6 times, right? Every time we
Yeah.
choose something here, we're repeating it 6 times. So what do we have to divide by to account for that? If we're off by
6.
exactly, we're to divide by 6, right? 55 times 54, 53 divided by 6. Okay, so this is the answer. But remember, so 6, it's correct. That is correct. But just in general for combination problems, so if we want to figure out how many ways there is to order something, like a 4-person group or a 5-person group, then it's just going to be the number of people factorial, right? Because 3 factorial, for example. So JBA, it would just be 3 factorial, which equals 6. Okay, if I was choosing J, B, A, and G, maybe add George to the group, then I would divide it by 4 factorial. Okay. And we went over this, right? So that's how we order, we can choose like the number of orders we can put a number of people by, right? So 4 people, we can put them in, or we can switch the order around and we could get 4 factorial different permutations. So we'd have to divide it by 4 factorial. Make sense?
Yes.
Okay, let me know if you're confused. Okay, so this is you're right. So this is just for Republicans now. Okay, so this is just for Republicans. Now we're not done the question yet. We still have Democrats. Okay, now for Democrats, we have 45 in total, and we want to choose just 2 Democrats. Okay, we want to choose 2 of them. So can you think of an equation for this? It's the same way we did the Republicans. It's just now we have different numbers to work from.
So we can choose from 45 times 24.
Okay, so 45 times 44. And what do we do to account for different
Divided
orders?
by 2.
Divided by 2, yes. Okay, it would be 2 factorial, which equals 2, right? So same thing, divided by 2, and this is for Democrats. Okay, so perfect. Now we have the total number for Republicans, and we have the total number for choosing Democrats, okay? Now we just want to combine the two. So do you know how I combine the two, right? So we want to just make a combination of this, because first he's going to choose 3 Republicans, and then he's going to choose 2 Democrats. So do you know how I combine? What do I have to do to these two large numbers now with them to combine the result? Do you know what I have to do?
We add them together.
Not add them, okay? Because remember, this is an and statement, meaning we're going to choose 3 Republicans from 55, and we're going to choose 2 Republicans from 45 Democrats. If this was an or statement, and I told you it was one or the other, in that case, we could add them. Because it's an and, what do we do for and? We don't add, we
times.
Yes, we multiply, okay? We multiply, okay? So we just multiply that, okay? 55 times 54 times 53. Let me just write the final down. 55, 54 divided by 6 times 45 times 44 over 2. Okay, and you remember why we multiply instead of add, right? And like which cases we add, which cases we multiply, and why it works that way, right?
Yes.
So if we have a guy here, he's a, and then he goes down this path, and then he can go down this path, or this path, right? Those are 3 different paths. So if we look at the amount in total, so let's just say that's A, B, C, then we have to add this, right? So he goes down 1, and then he has either this one, he has 2 second path, third path, fourth path. So that would be 4 paths total we're adding. Okay, so these are the cases we would add when it's an or, when he has to make a choice. But in this case, it's an and, meaning he's going to do both. He's going to go down this path, and then this path, and then this path. Make sense?
Yup.
Okay, perfect. Okay, so now let's do this question. Okay, so this is the same idea as the last question, this question. So I want you to take a few minutes and do it. I'll read the question once, but just
Okay.
remember it's the same idea as the last question. So we want to go about the same approach. Okay, let's read the question. So we're saying that my state's lottery has 30 white balls numbered from 1 through 30 and 20 red balls numbered from 1 through 20. Okay? In each lottery drawing, 3 of the white balls and 2 of the red ones are picked. How many different possible combinations may be drawn? And I said in brackets that order does not matter. Okay, so do you get the question? Does anything not make sense?
Yes.
You get the question?
Yup.
Okay, perfect. So take a few minutes and try to come up with an answer and just explain how you think why that answer is correct. Okay. And let me know if you're stuck.
So for the white ball, we use 30 times 29 times 28 divided by divided by 6.
Okay. Why do you say okay 6? Yes, perfect.
And the red ones are may you go up for the question?
Oh, sure.
Red is 20 times 19 and
Mhm.
divided by 2
Perfect. Okay.
and times them together.
Okay, perfect. So yes, exactly like the other question, right? For white, we just did 30 times 29 times 28 divided by 3 factorial or 6, like you said. And then we just had 20 times 19 divided by 2 factorial. Okay, so exactly like the other question, right? Because and just a quick summary on how we get these forms, right? So we have 30 for the first ball when we pick, we have 30 options, and then for the second ball, since we've already picked one, we now have 29 options, and then for the last ball, we've already picked 2, so we just have 28 options left, right? And then so this is just like the problems we used to do. The only additional step we're doing is dividing by 3 factorial, because we have to account that they can be ordered 3 factorial different ways within themselves. Okay, let's delete that. Okay, so I think this unit we're good with. Let's go on ahead to the next unit. Okay. 4.3. Again, 4.3 is how to compute combinations. Okay. Now we have been computing combinations in the last question, but we weren't using a specific formula. We had to think about the problem every time. But there is actually a specific formula that we can use to solve these problems. Okay. But sometimes it's just easier to think about it instead, because the numbers can get quite large with this formula. Okay, so just remember the general form of all these questions is that usually we have an n number of people. Okay, so an n number of people to choose from, and we're choosing our people, okay? Our people chosen. Okay, and the form to write these questions would be something like this, NR. So this is like the equation, okay? It's kind of like, it's like saying A plus B, right? And we add them. NR is the equation. So this is the forward N choose R. And what it means is we're just choosing R people from N total people. Okay, and we're going to be learning the formula for this. Okay, so let's see. Here, let's go ahead with these questions. I'm sending you a few questions right now. I'll send you a link. Okay, you can check chat for the link and you can just follow along with the questions here, okay? Okay, so let's go ahead and start the first one. Right, okay, so the first one says we want to determine a formula for the number of ways to form an R-person committee from a total of N people. Okay, so that's this general formula right here, right? R people, we're choosing R from a total of N people. Okay, so let's see how we've been doing the previous questions and let's try to apply it to this question. Okay, so this is just a general case. Okay, so usually we, if there are N people total, then we know for the first option, we have N, right? We can choose from an N number of people. So we have N total options. And then for the next one, we always have one less, right? Because we've already chosen one here. So now we have one less. So we're just going to do N minus one. Okay. And then for the next one, we have another one less from the previous one. So now we have N minus two, right? And we just keep going. We keep multiplying until essentially we've subtracted R, right? So let's look at that Republican question again. We had 55 Republicans and we only wanted to choose 3. And you did 55 times 54 times 53 because we're only choosing 3, right? So we're basically only writing multiples up to R times, okay? And not only are we writing it up to R times, you may have noticed that the last number, 53, is just 55 minus R minus 1. Sorry, 55 minus R, or so 55 minus 3 plus 1. Okay, so let's keep going. N minus R plus 1. Okay, so does that make sense so far? Are you following along so far?
Yep, I am following along.
Okay, so just to visualize with that other example, right? So for 55 Republicans, and you were choosing 3, we did something, what you did was you just said 55, right, times 54 times 53. Okay, in this case, R happened to be 3, so we only have 3 numbers here. We only have 3 numbers here, and the last number is 53, which is 55 minus 3 plus 1, right? So that works out. Okay, so that's just a quick example to visualize it, so we're not working with general variables. Okay, so this, as I was choosing now this would be our final answer if order did matter, but order doesn't matter. So we're not done, right? So what have we been doing when order doesn't matter? What have we been dividing by something, right? Do you know what we're dividing by?
We divided by R. Yeah, by the people that
R.
chosen.
Exactly, right? Because we've always been dividing by the number of people we have to choose. So when we had 55 Republicans and we chose 3, we divided by 3 factorial. Because when we choose those 3 people, there are 3 factorial different ways to organize, like to change the order of them, right? So we have to remember that we don't care about the different orders. So we divide it by R factorial. Okay, so this is our formula so far. Okay, we have N choose R here is equal to this gigantic equation over here. Okay, but let's see if there's an easier way to write that. Okay, so let's simplify the numerator a little bit. Right now we have it going from N and we have it going all the way down till N minus R plus 1, right? What if we just have it keep going down till 1, right? So let's just say we take the numerator here. Okay, and we do this. So this is the numerator that we have. And what we do is we do this. Okay, so same thing here. And then right at the end here, okay, I don't know if I have enough space, 1 second. Okay, right at the end, what we're going to do is we're going to make it so that we can write the top as n factorial, right? And to, you know what n factorial is, right? It's just we multiply from n and we multiply the next lowest number all the way till we get to 1.
Yeah.
Okay, so right now this is n, so if we start from here, n, and it's going down to n minus r plus 1. So what we're going to do is after that, we're going to multiply by n minus r. And then we're going to keep going until we get to 2, get to 1. Okay, and then remember, we can't just multiply numbers at the top now, right? So no, because at this we're changing the number, right? It's a different number, so we have to divide on the bottom by the same thing. Bless you. Okay, so we're going to divide whatever we multiplied on the top, we're going to divide on the bottom. So we multiplied an additional n minus r, right? And then we're just going to, and then we multiplied that and we kept going down until we got to 2 times 1. Okay, so really we could technically cancel this out, and we just end up with the same numerator again, right? But we put that there, we put those there for a very specific reason. We're going to use those to help us simplify, because now, 1 second, we can write, you may have noticed that we can write the top now can be written as n factorial, because now we're starting from n and we're going all the way down to 1, and we're subtracting 1 every time, right? So the top can be written as n factorial. The bottom, it starts from n minus r and it goes all the way down to 1, okay? And what that is really is just n minus r factorial, right? Because the first number, n minus r, will evaluate a number, right? So if n is 55 and r is 3, like the Republic, when you're choosing the Republicans, then it would just be 55 minus 3, or 52 factorial. Okay, so n minus r is 55 minus 3 factorial, or 52 minus 52 factorial. So the bottom, you can just write as n minus r factorial. Okay. Now, this was just for the numerator, right? This was just for the numerator. Like from this equation, we just looked at the top. We can't forget about the bottom. So if we bring it back and we say n factorial, n minus r factorial, which is the numerator, and then we divide it by the denominator again, which is r factorial, right? And then this is division by fraction, so it's just multiplying by the reciprocal, and we should end up with, okay, so this right here is our final equation. Okay,
yeah.
So when we have n choose r, we'll get n factorial, n minus r factorial times r factorial. Okay, so this you'll have to know.
Okay,
so this is an important equation, and this is the equation for anything. So whenever 55 choose 3, you can just plug that in here.
that's the formula, right?
Yes, this is the formula, right? So this is what we derived, right? So this right here is this right here is the unsimplified formula, right? And then we simplified it by making it into n factorial and making the bottom into n minus r factorial, and we ended up with this final formula. Okay, so this is the how to compute combinations. Okay, so if anyone ever asks you, you need to pick out 3 cards from a deck of 52 cards or something, this is the formula you want to use, okay? Well, in order doesn't matter. Okay, so now the one thing is, remember, so the bigger your total pool is, the harder it is to calculate this. And sometimes calculator might even be, it can't calculate, right? So if we have like 55 Republicans, then our n is going to be 55 factorial. And then our bottom is going to be 52 factorial times 3 factorial. But 55 factorial, 52 factorial, these are hard numbers to calculate, right? Like if we're just doing 55 times 54 times 53. So let's see this next question will help us out a bit. Okay, so take a look at the next question, 4.5, and they want us to compute 11, choose 4. Okay, so let's go ahead and plug that into the formula. Okay, so 11, choose 4. So can you help me out? How is that going to look when I plug it in the formula?
So the formula is so 11 factorial over 11 minus 4 factorial and 4 factorial.
Perfect. Okay, so we have the equation, we can plug it in. But these are, it's not like 55 Republicans, but 11 factorial is still pretty big to compute, right? 7 factorial, it's not as bad, but these are annoying to compute these all the times, right? If you're working and you have to do 11 times 10 times 9. So these are big, but let's go back to one of the earlier steps when we were deriving our equation, right? So let's just think about this for a second, right? So let's further solve this. 11 factorial over 7 factorial times 4 factorial. Okay, now do you see any way that we can simplify this just by looking at this equation? Do you see any way that we can simplify this?
We can, I don't see any way. So like 11 factorial is 4.
Sorry?
So like 11 factorial, there's like 11 times 10 times 9, and there's 4 times 3 times 2 times 1, so you can simplify it out.
Okay, so you're telling me to take out the 4 times 3 times 2 times 1 from here and then cancel out 4 factorial here, right?
Yeah.
That's very good observation. That's what we're looking for, but I'll do you one better. What if we just cancel out the 7 factorial and then cancel
7 is more. Yeah.
Right, yeah. So because that's a bigger number, right? So we can cancel it even more. So if I do that, so I'll have 11 times 10 times 9 times 8. And then everything from 7 times 6 all the way to 1 will be canceled out with a 7 factorial. And then on the bottom, I'll just have 4 factorial left, right? So this is much easier to compute now. This is way easier to compute. We're only multiplying 4 numbers at the top and only 4 numbers on the bottom. And this is the form you also recognize, right? Because before, when you didn't know the equation, if I told you to form a committee of 4 people from a group of 11 people, right? A committee of 4 people from a group of 11 people, you would have told me 11 times 10 times 9 times 8 for choosing the 4 people. And then we would have divided by 4 factorial, right? We divided it by 4 factorial to account for the different orders we could put them in, right? So this is what you recognize too. So it's right. So in the end, it's all related, right? Whether you use the equation, whether you use the full form, it'll always get you the same answer. It's all related. So you can always make one look like the other, right? So to get here, we simplify 11 factorial and 7 factorial. Okay, so that'll help because when we're doing lots of these questions, you don't want to multiply so many numbers. Okay, perfect. And then if we solve that, right, if we multiply all that out, we should get 330. But if there's a lot of numbers to multiply or something, sometimes you can just leave it in this form. As long as you understand the form, it's fine. But when they're small, you should just multiply them out. Okay. So let's move on to the last question here. Okay, so problem 4.6. So we have a round robin tennis tournament consists of each player playing every other player exactly once. How many matches will be held during an n-person round robin tennis tournament where n is greater than 2? Okay, so I hope you remember this question. We did do this question, I believe in the last unit, okay, when we were doing the summation rule. Okay, and I'm just gonna do a quick refresher of how we did it last time, right? So we have n number of people, right? N number of people, so we don't know exactly how much people, but we have n number of people. So we'll have player one. Player one will play a game against player two, against player three, against player four, and he'll keep playing a game. He'll play against everyone including player n, right? Because that's what the question says. It says each player will play exactly once, and then they'll play each other exactly once. Okay, so player 1 plays against player 2, 3, 4, 5, 6, and he keeps going until he plays against player n as well. So in total, he will have played n minus 1 games, right? Because he doesn't play against himself. He plays against everyone but himself. So that's n minus 1, right? And then we get to player 2. Player 2 will play against player 1, but we've already counted for that in the first game, right? We've already said player 1 plays player 2. So that's no difference from saying player 2 plays player 1, right? So we're not gonna count that again. And they're not gonna play themselves. So we're gonna start from player 3, 4, 5, all the way to n. And player 2 is gonna play n minus 2 games. Okay, because he's gonna play exactly 1 game less than oh, sorry. Well, no, he'll also play n minus 1 game, sorry, but n minus 2 unique games. Okay, there's n minus 2 unique games because we've already counted player 1 versus player 2. Okay, and then, for player 3, if you see the pattern here, for player 3, the obvious pattern now is that they're each going to be playing 1 less unique game because we've already counted the game in the previous one, right? Because for player 3 versus player 1, we've already counted here. Versus player 2, we've already counted here, right? 2 and 3. So he's not going to verse himself, obviously. And then the next game is going to be against player 4, player 5, and then all the way to n. And that's going to be a total of n minus 3 games. So you get the idea here, right? So to get the total number of games, we're going to have to add the first n minus 1 games plus n minus 2 plus n minus 3. And then we'll keep going down until we're just eventually left with, we're eventually just left with 2 games and then 1 game. So we keep adding, right? And then remember, so we learned the summation rule for this, right? So this is just equal to n times 1 divided by 2. And we learned this equation in unit 3, right? Okay, so
yes,
right. So there's one more way. So this is the way we thought about this problem before, right? So we figured out how many games how many unique games each person would play, and then we just added them together, and we found out that when we have a summation in this form, we can just write it like this. Okay, we can write it like this, but there is a way to think about this in terms of combinations. Okay, so it's a more simple to think about. So let's think about it. Okay, so how about if we think about each match in the tournament as a 2-person committee? Okay, so we think about each match as a 2-person committee because just like a committee, each match is unique, right? So if we're choosing 2 people from a 10-person committee, then we can choose person 1 and person 2, person 1 and person 3, person 1 and person 4, and then we can choose person 2 and person 3, right? So it's just like it's exactly similar to choosing a match from number of people to choosing a committee from a number of people, okay? Because these 2 questions are basically asking the same thing. Okay, so we can think about each match in the tournament as a 2-person committee, right? And just like committee, because remember how when we were looking at player 2, we didn't count player 2 versus player 1 because we had already done player 1 versus 2, right? So this is just an example of order not mattering, right? Order does not matter. These 2 are just one game. They're both just 1 game, right? So if we think about it from that perspective, what do you think the answer will be, right? So it's from combinations perspective, right? Try deriving the answer. So we have a total of n people and we're choosing 2, right? We're choosing 2. So do you know what the answer will be?
the answer will be n n times n minus 2.
N minus 2, okay.
Divided by 2.
Divided by 2. Okay. Good, but how did you get n minus 2 here?
I'm not. Wait. Isn't the bottom number?
So the bottom number 2 is correct. That's perfect, right? And then this n.
Oh.
Right?
So okay.
So but this n minus 2 is incorrect. So how did you get n minus 2? Do you have a reason why?
I don't know.
Okay, so the reason, remember, so what we've been doing is it's if you look at the general equation, it's going to be I believe n factorial over n minus 2 factorial times 2 factorial. Okay, so n minus 2 is 2 less than n, right? So it's going to cancel out every in this n factorial. It's just going to be the first 2 numbers multiplied, right? Because we're going to cancel out every number after that with this one, right? So if it's the first 2 numbers multiplied, then we're just going to have n, and the number immediately after it, which is going to be n minus 1, right? N minus 1, and then that's going to cancel out. We've already canceled out this part, right? And we're just going to be left with 2 factorial, which is 2. So n times n minus 1, 2 factorial. Okay, so this part here is wrong. So you're close, but it's not n minus 2.
Okay.
It's n minus 1.
N minus 1, yeah.
I think there's a mistake there, but yeah, so it's we've just thought about it from a combinations perspective now. So it's the same answer as before, which is good, right? We want the same answer as before. It's just now we've thought about each match played in this tournament as a 2-person committee. So we're choosing a unique 2-person committee from these number of players, and we're saying order doesn't matter, right? So that's basically n choose 2, and you can figure out the equation for that, right? Okay, so I think that's all for these practice problems. Okay, so let's continue on to the exercises. Let me send you the exercises. So there's some good ones here. Okay, so you can check the link in chat. Sent you the problems. Okay, so this is what we'll do. I think for the first, okay, we'll do a few of them because 4.31, there's a lot, there's 9. Okay, so what we'll do first, I'll give you one question. You do it. Let's see how you do it. If you do it well, then I'll give you 3 questions, 3, I'll choose another 3, and then you can do those 3, and we'll check the answer, and then we can move on to the next questions. Okay. So for this first one, let's start with part B, 4.31B. Okay, so that's 5, choose 3. Take a minute or 2 minutes, 3 minutes, however long you need, and tell me if you can figure out an equation or the final answer to this question. Okay.
So it's 5.
It's 5. Okay.
Times.
Go. Yeah.
5 minus 1.
Okay. Yeah, that works. Yeah.
Divided by 3.
Divided by 3. Okay. And is that your final answer?
Yes.
Okay, so let's take a look. So the top looks good, right? So we have 5 times 4. the 3, the bottom, the 3. So why are you dividing by 3 here?
Because the bottom number is 3.
Now that's true, but are you forgetting something?
Wait.
Right? Because we're choosing 3, right? We're choosing 3 people, but how many different ways can we arrange those 3 people? If I have the letters A, B, C, how many different ways can I arrange these 3 letters?
Oh, 6.
6. And so how do you get 6? Instead of 3, what would you do?
Times 2.
Well, 3 times 2, yes, but so you wrote 3 here because that's the number of ways, like you said, that's the number on the bottom, right? But now we're saying it's actually 6 because that's the number of ways we can arrange 3 numbers in different order. But then how would I, because we don't want to do that every time, right? Because what if it was like 7 choose 5, and then it would be, how many different ways can I arrange five different letters, right? So if you're just looking at the bottom number, what do we have to do to this 3? Yeah, it's true, it is multiplying by 2, but is there something that the equation tells us that we do instead of 3, like just in general? Just, because if this was like 8 choose 5, then we can't multiply by 2, right? So what would the bottom number have to be?
The bottom number have to be
So it's 3 factorial, right?
Oh yeah, 3 factorial.
Right. So yes, we forgot about the factorial sign, but okay, it's fine because in the end we learned about just remember, it's important. It's more than remembering the factorial sign. It's more important to remember why we're dividing by 3 factorial in the first place, right? And remember, so how many different ways can we arrange the letters A, B, and C? And like you said, 6 ways, right? So that's why we're dividing by 3 factorial or 6. Okay. So if this was something like 8 choose 4, then we divide by 4 factorial. And 4 factorial is a number of ways that we can arrange those 4 letters. Okay. And you know how, and so just another visual example, right? So if we're arranging A, B, and C, we have 3 digits, right? And remember, for the first one, what we can put any of the 3 letters there. For the second one, well, we only have 2 letters left now because we already used one of them. And then for the last one, there's just one option left, right? So that's 3 times 2 times 1. That's 3 factorial, right? All right. So let's try another question now. Let's try another question. Let's see. Let's try question D. Okay. 8 choose 2. So take a few minutes and try to come up with an answer for this one.
So 8 times 8 minus 1.
Okay, so okay, good. Yes, keep
divided
going.
by 2.
Yes, right. 2 or 2 factorial, which equals to 2, right? So just as long as you know that. Okay, so divided by 2. Perfect. Okay, so it looks like you're getting the hang of these. So I'm just going to tell you now, do questions E, do questions G, and do question H and I. Okay, so do those 4 questions and write down the answer for each of them. Okay, and then you can just tell me the answer. Okay.
Okay.
Perfect.
So for E, I got 9 times 9 minus 1 divided by a factorial.
Okay, so 9 times 9 minus 1, 9 times 8 divided by 8 factorial. Perfect. Okay, so you could also, okay, actually that's fine. Okay, yeah, perfect. Okay. So let's go on to G. What did you get for G?
G, I got 11 times 11 minus 1, which is 11 times 10 divided by 9 factorial.
Okay, so let's see. So you got 11 times 10 over 9 factorial. Okay, 1 second. Okay, perfect.
And for H, I got 50 times 49 divided by 2.
Okay, so you got 50. Let's see, 50, choose 2, and you got 50 times 49 divided by 2.